So today welcome you all to exciting tutorial on solar power generation prediction using Python, right? So in this video we'll build a machine learning model using multivariable linear regression to predict solar power generation based on key environment factors like temperature, solar irradiation, wind speed, humidity, right? So how far this program is developing? First, we generate a synthetic data set by using predefined functions. Then followed by we develop a what's called linear regression model. Then evaluate the model. Then we will see the visualization. So four stages: synthetic data set generation, linear regression model development, evaluate the model, see the results. Okay, this is a program here, right? First, you got to see this is a basics library. Already each library, what purpose you have an experience. Okay. If you don't have, please refer my previous video. You can get it. Okay. NumPy, Pandas, and Matplotlib. Okay. These three are basics library. If you want to develop any machine learning program, first we can call the default this library. Right. Once it is calling for running, you got to click run button here. Okay. This automatically it will be run. Okay, just I show you, right? Come back here. Then second one thing is it is represents, see, it is our these three codes are used to machine learning model. Okay, first from Scikit-Learn I'm selecting a model selection as a module. So in that model I'm importing train underscore test underscore split, which is it is a class. Okay, three things, it is two are classes. Okay, these classes are instant of model, which is here I'm selecting model underscore selection. So model underscore selections, why I'm using here, it is used to train the data sets. Once the training is over, we have to test the data sets. Okay, so this we should to split the data set as a train and test. For this case only we are using this command, train underscore test underscore split. Then followed by is we are going to perform a linear regression model. So that here I'm selecting linear underscore model. Okay, then it from the model importing linear regression task here. Okay, because of linear regression is there, linear classification is there, here I'm selecting linear regression here, right? Then followed by metrics. Metrics are which is used to evaluate our machine learning model, how far it is good. That in other word, it is prediction accuracy. Here I have taken two factor, that is a mean score error, R score error, right? Now we come back, generate a large data sets with this command. Okay, the command np.rand.seed, it is used to set the seed for NumPy's random number generator, ensuring that the what's called generation random numbers are the same each time you run the code. Whenever you run the code, all the time it will generate a same random number. That is the purpose we are using np.random.seed. Okay, right? So number of samples here is we are selecting 100 number of sample. Okay, come back. Now we are going to generate a data sets. For generating data sets here, first actually four variable only considered because of multi-variable problem. Okay, that is the reason: temperature, irradiations, wind speed, humidity. Okay, four factor I consider here. So temperature, for generating temperature, np dot random. Okay, np dot ram dot unif, this function we are using here to generate a uniform distribution data sets. Okay, so here you got to see NP is a random, what's called NumPy library. In that NumPy library I'm selecting random. Okay, why? Because I'm going to generate random variable, and how it is going to generate, it is uniformly. So what is the meaning of that? If you are using this code, it is used to generate a random floating point numbers from uniform distribution between the specified range. Okay, it will go here, it will generate a uniform distribution between the adjacent numbers. Okay, so it is range is started from years of temperature, so 20 to 40 degree range I selected here. So number of samples, how many number of samples, it is here already predefined 100. So 100 number of samples it is going to generate. Then followed by irradiation. Okay, np data, same function I am using here. Irradiation I am selecting here 400 to 1000 range. Total number of samples is 100 amps. Okay, then wind speed also considered here as a factor. This because of wind speed display wind speed and irradiation, all the things are play major role. Okay, what are the critical factors which are influencing on what's called our power generation? Those factors only considered here. Okay, so wind underscore speed, it's a variable which is store the wind speed data to this ranges to 10. Then followed by humidity 30 to 80. I'm selected here as a humidity. Okay, if you don't understand, please see the here, it will give you the clear cut instructions. Temperature range I'm using here 20 to 40 degree. Okay, then irradiation range is 42,000 watts per meter square. Wind speed range is 2 to 10 miles per seconds. Then humidity range is 30 to 80 percentage. Okay, right. So four variable we are selected here. Then what is called we are developing one relation. Okay, generator power output with some noises. Okay, so what are the factor influencing on power output? Okay, for example, temperature is here 0.8 percentage it is influencing. Okay, then 0.5 is irradiation, like that. Each factor I consider here. Okay, so what are the factors are consider influencing on our power output? Based on that, here I am selecting one what's called noise. Okay, so noise is essential because it is synthetic data sets. So without noise, data sets maybe lead us to wrong direction. So that here I am using data sets with some noises. Okay, come back to the in future lecture. I tell you, I separate like our what is the importance of these noises. Okay, right. Okay, come to the we have to first we generate data sets. Now we are making data sets as a data frame. Okay, temperature, temperature, radiation, wind speed, humidity, power output, these are all that's called what's called variable we are generating already. Okay, so power output, so here maybe you have to refer it. These four parameters are as a what's called the independent variable. Power output is a dependent variable. So these four are used to what's called used as we have to store. This is an x-axis, it is used to y, that means a target. These three are futures. Okay, come back here. So now we are defining the futures and target variable. Futures you have to see, so temperature, irradiation, wind speed, humidity, these four are as a future. Then what is the output is represented, see here is a target variable. Okay, right, come back. Now this is a step, this step is which is used to split the data sets for training as well as testing. So x underscore train, x underscore test. Okay, so total data sets we are splitting four. First one being train, then test, followed by y train, y test. What is the meaning that x is has all the four. So four what's called futures. These four futures we converting each and every futures to two. Okay, so automatically we can get it what's called training data sets, testing data sets based on this class. Okay, you see this is a train underscore test underscore split. This is a class we are called here. Then we pass the what are the values needed. What's called x comma y. It is the original data sets. If that data sets we are selecting test underscore size 0.2, which is indicating the 20% of data which is used for to test our data set, our algorithm, how it was developed. Then followed by random underscore state, which is represented the random variable. Okay, a selection of random variable. Then once it test and what's called split is over, then we have to initialize the train and initialize and train the regression model. Okay, just we got to create one variable, that's a model, right? Then it is here called as an object. Then followed by we have to store this what's called linear regression model to the model object. Okay, right? Just nothing, just we are calling what we are want to do, linear regression algorithm only we are used to train the our model. So that linear regression model call, that model stored in model. Okay, that is here, it's called as object, right? Right, those objects what you are doing here, model dot fit. Okay, just we are fitting the train and x train, that means future, followed by y train. Okay, that's a target variable. These two things are we are passed to the model, right? Come back. Now we are going to make a predictions. So while start to do predictions, first you have to see y underscore prediction. Okay, it is used to store the value. So model prediction. So model dot predict. Okay, so this model is already previous code, please see, refer it. This model what it has complete our already it is stored in linear regression algorithm in that model. In that already we are fit the train x train y train data to the linear regression model, right? Come back here, model dot predict. Okay, we are what's called we are going to now predicting x underscore test. Okay, why? Because of already data sets we have. So test data sets already got out target variable. With the help of with accuracy we want to predict, okay, whether model is properly trained or not, right? Then once prediction is over, we should evaluate the model performance, how it is model is performing, okay, based on our predictions. For this case here I'm selecting mean score error, r score error. So means underscore r score error. Okay, so in that two variable we selected test followed by prediction. So test what we have, prediction what is. So both the variables are we are comparing. We try to find a what's called mean score error. R score error also same. Okay, here test and predicted, these two variables are passed to the R score so predicament function. It is used to find. Then this model is ready. We need to print this four parameter to evaluate the model. First one thing, mean score error, followed by R score error. Here I consider model coefficients, that is one of the key factor here. Then followed by model intercept. Okay, right? So model coefficient which is used to how each and every model influencing on output. Okay, right? Compare. Then we have to draw the plot here for visualization purpose. Plot actual versus predicted value. It is we are going to here plot PLT function which is represents, it is available Matplotlib library. In that scatter plot we are selected here. To scatter we pass to two values, y test, y predicted. Then we fix the axis with the help of this predefined function. So minimum value, maximum value, followed by minimum and maximum. Okay, right? Okay, then followed by it should be in a red color. This line is a double what's called hyphen lines. Okay, that's been dot, whatever you based on your requirement you can do it. Then followed by we fix the label with the help of this command. Plot dot x label, which is used to here actual power. Y label already I fixed predicted power. Then title is actual versus predicted, that's a plot title. Then plot which is used to show the figure, right? So now program is developed. So it is necessary to run all the files. So instead of all the one by one, I will say that run. First this is already run. So I come back second one thing I am running. Okay. Then third it's run. Okay. Then fourth, right? Then come back fifth. Okay. Fine. Next. Over. Then splitting. Okay, then come back. So linear underscore model is smartly developed. Then make a predictions, right? So once the prediction is running over, then I print the predictions, right? So prediction here you got to see mean score error is around 94, R score error is 0.98, model coefficients are these are model coefficients. Okay, model intercept this is okay. These three parameter I'll give the explanation last of at the end of the video. Okay, very important that point. Okay, now come back actual versus predicted output. See, so actual versus predicted, x axis represents actual power output, y axis represents the predicted power output. So this is a regression line. Okay, how data sets are this and all prediction power. Okay, how it was, right? So almost very close, only few data only very large. Okay, right? Now compare the interpretations. So from the interpretation you got to see program already run, already you maybe refer this video. Okay, you can get it more output. So here predicted power output followed by actual versus predicted power output is what's called is the title of the figure. Already we know why it was coming. So here we take in predicted power output as a y-axis, actual power output is a x-axis. So we try to find relation between these two. Okay, right? Come back. Mean score error. Mean score error we got a 94.2112. Okay, what do you mean by mean score error? It measures the average square difference between actual and predicted value. Okay, it shows you square difference between actual and predicted value. Okay, so what is the meaning of that? A lower MS indicating that models predicted are close to the actual value. This may be offer very low value only. Okay, so it means that that is an average. Okay, score difference between what is the value we got, 94.21. Okay, which is indicating that almost we have predicted perfectly. What is the formula here? Behind the mean square error is 1 divided by n summation of I equal to n to n, that is the number of samples, y I, that means current iteration, followed by y got. Okay, it is represents what's called square difference between the mean square error. Then come back R square error. For R square error, what is the definition? It is measured the how well the independent variables. So here independent variables are temperature, irradiation, wind speed and humidity. Okay, so how well the independent variables explain the variance in the dependent variable. Okay, how it is variance. Okay, it shows the relation between the dependent and independent variables variance only. Okay, so here an R square value is 0.98, so which is indicating that 98% of variance in the solar power generation is explained by the given input future. Okay, so R square error always close to 1, it is almost 0.98. So prediction accuracy is good, not excellent, it's very good. Okay, why? Because of it is a very simple data sets. If your data set is large, then automatically R square error is going to vary. Okay, right. So how you do it? What is the relation mathematically? R square, which is equal to 1 minus S into S residual divided by S into S total output. Okay, here R square error is, this is a formula. Then followed by model coefficients. Here we are considered 4 variable, each model coefficient is represents. First one belongs to temperature, second one is represents the irradiation, third is wind speed, fourth is humidity. Okay, so each coefficient represents the change in the power output per unit increase in the corresponding future. Okay, for example, you come to here, temperature 1 degree for rising, how much power it's going to increase? 0.6563 watts is going to increase. Okay, suppose irradiation 1 watt per meter square is increasing, at the time 0.4961 watts is going to increase. So this model coefficient is very important factor to predict, to perform any what's called a machine learning model, right? Okay, then come back to intercept. Intercept here, actually intercept is why I'm not putting here. Intercept here invalid. Mathematically it is invalid for this problem. If you any further problems comes when it is value everything valid, so remaining those information we will discuss in future classes. Okay, right. So very simple, very basic model followed by model selection, then come to the random function which is used to the random sample generation. If you want each and every things, what is output of each and every cell, just to go call that variable, just run it. See, number of samples we are going to 100. Come to here, print okay, temperature. Okay, right, temp is missing, right, run it. So like that each and everything you can print and see it is corresponding output. Okay, wind underscore speed. Okay, right. So we can refer each and everything, right? Here also print power underscore output, right? Now we can run, right? Power underscore output is not defined. Why? PWER, R is missing. Okay, right. Be careful, case sensitive. So this is a power output. Now we need as a data frame. If you want output means print df data frame. You can get complete data. Okay, how data is going to vary. Okay, first I want to remove this print, otherwise it is confusing you. Right, now got to see. So we have 100 data sets. Temperature, irradiation, wind speed, humidity, power output, how it is varying. So this is your complete data set which is used to perform the what's called our program. So here it is represents to split the data sets. We can print data sets to data sets. Okay. Then after splitting, also if you want to see, you can here you got to see print print okay x underscore try. If you want, you can refer it here. It shows what is the data set for printing. Okay. I don't want this is I want now y underscore test. Okay, y underscore test data. Just run it. We can see the test data for things. Okay, so like that we can refer with the help of printf function. We can easily found the things. Okay, right. One more thing, it is accuracy is very high, but this data set is very small. So only we are taking 100 samples, 100 samples to perform the what's called prediction, what's called it's a power generation based on the input. Okay, if your data set is increasing, then automatically you are possible to what's called R square error may be getting, maybe it's maybe low or high based on the developing program, right? Okay, okay. Maybe I hope you are understanding. If you have any doubt, you can comment it. I'll respond the query through comment box only. Okay, fine. Thank you. We'll meet in next lecture. Uh, plans to now two things we covered. One is simple linear regression on previous for predict EV range. Then here what's called solar power prediction multivariable. Okay. In future we are going to perform uh, polynomial regression to predict wind power generator. Okay, like that each and every video file will every algorithm will apply some real world problem we try to find. Okay, so after 2 to 3 classes over, then we go for we should take a very what's called accurate data sets or real time data sets from unrelated sources. Those data sets we try to predict the algorithm. Okay, fine. See you next class.